of fun stuff. So let's get at it. If we go to our website here, here, let me make sure all my chats are working as well. Also, I hope YouTube isn't being silly anymore, and it doesn't have like subscriber only chat on. Also, it's not finding my chat, dude. What the hell? 1 sec. Hold, please. Dun, 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 dun. Dun, 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 dun. We are most definitely live. I know we're live. Or maybe we're not? No, we should be. Yeah. Yeah, we're on. Bum, bum, bum. I can always like pull this in manually if I have to. There we go. Okay, there's our chat. Dude, what? Why does it default to subscribers only? That is so annoying. I don't know why it does that. Anyone can chat. Okay, there you go. I don't know why it does that. All right, let's see. First question's on the queue. We already got some submissions. Breasticles, 1, and Equita. All right, let's spin the wheel and see whose question is going to get picked here. Looks like we're starting off with a hard one. Breasticles, that's you. We're starting off with pain. I love pain. Breasticles. I kind of empathize with it, man, dude. My like joke name during college was like Pex McGee. Because I had prominent pectoral muscles. I couldn't fit all of it because he yaps, but it's 6.4. Yeah, you come on the stage, Breasticles, if you want to talk. Maybe help explain this. We'll give it a good college try. I have the book.
Same book. I sent you the PDF. It's
yeah, I appreciate
6.4, and I think it's page like 241 on the PDF.
Let's go check it out.
Yeah, 241 on the PDF.
I love how this is like undergraduate lecture notes. This is very much not. It's not fucking undergraduate, dude.
I would call it undergrad. I mean, I'm making my way through. I'm only a sophomore.
This is upper division, at least. At the very least.
Yeah, definitely upper division. That's for sure.
It's like 3rd or 4th year undergrad, or I don't know. Even some of the stuff, like I didn't even do a grad. All right. Where's the question? Here it is. Okay. Okay. Oh, okay. I'm just gonna like, whatever. We'll leave this. Is it possible to change the outcome of a race by measuring it? I mean, according to Schrodinger, and yeah, definitely, yeah. It's called entanglement. Okay. Oh yeah, here we go. Uniform density linked chain initially heaped over the edge of a table falls from the table as it slides without friction. If X is the length of the chain hanging over the edge. I know this problem. I've heard this one. Yeah, it's fun. Not. Find a differential equation of motion. X is a function of t. Say without derivation that the equation of motion is. So he just stated this. Some German.
Yeah, I mean, obviously you should just know off the top of your head. That's.
Well, I guess in 1943, people weren't really questioning what the Germans were publishing.
Yeah, fair enough.
They were like, yeah, you want to say that? Cool, man. Great. In this dot notation, X. Okay, cool. Dot is a pretty. Oh, okay. Newton's the one that did the dots? Bruce says, so this means there's a chance I can win the half marathon this weekend. There is a non-zero chance. 100%. Yeah, there's always a non-zero probability of something happening. I mean, everyone in the race could get a heart attack.
Disqualified.
And you would win. But the chance of that happening is quite low. Okay. He said its integration is somewhat difficult. Oh yeah. Yeah, somewhat difficult. Okay. Okay, show that Kiefer's equation and Sommerfield's equation are one and the same. That's Sommerfeld. Where the fuck is Kiefer's? Oh, Kiefer gave an interesting twist by converting it to determine the speed as a function of time, but rather as a function of the length of the chain. Oh, okay, cool. So we just want to show that this differential equation is the same as the other one. It's cool.
I believe so.
I can do that. Newton loved his dots because no one else needed to understand. Yeah, because Newton's just a... Shout out to Obi. Love you, Obi. Good to see you. And Simplex Pachinko. He's pretty good at differential equations. He wrote the book. Heikel says, what was the highest pure math course you did in university? Complex analysis is the highest level I did.
Complex was fun. I enjoyed
Complex
that class.
was fun. I need to take it again, honestly, because I don't remember any of it. But okay, here we go. I have not done control theory, Boang. I have not. I have no clue what control theory is. Yupanov. Sounds Russian. Russians were hardcore math people. Okay. So I want to get something that's in like DDT over to like DDX. And I guess we're going to use this relationship, right? Which is that like dx dt is equal to v.
Yeah, I'd assume so.
Right? So what if I like just plug that bitch in here and we'll like hopefully get something around here. And then I think I'm going to use a chain rule, right?
Yeah, I'd assume so.
Let's do something like that, right? So I can say that like dv dx. What is this? So what is that going to be? Is that like no. Yeah. No. dv dt maybe. Do I want dv dt though? No. I want to eventually... Okay, I have dx dt and I want to get to dv. Let me think. What's the chain rule I want to use here? What did we do last time? It was weird. I think it was dv dx. Which...
Let me look. Let me check what we did last time.
dv dx... Oh, wait, no. I can get dv dt. That was for acceleration, I think, right? Which I said is then dv dx dx dt. That works for a chain rule. Or I could say dx dt over dx is 1 over dt. Yeah. Yeah, real analysis is harder than complex. Complex is more like applied. Real analysis is like weird like number stuff.
Disqualified.
Yeah,
It can get like confusing. Complex feels kind of like an extension of calculus, basically. It's just like calculus for imaginary numbers. The latter. James says, okay, so we think we're gonna do this one. So dx dt over dx is 1 over dt. What? Why would I do that? Or is this kind of what we're saying? Or over dx equal to 1 over dt. Hi, Doc. Just really quick question. I hope it won't take too much of your time. But a coil of copper, when charged with electricity, should become an electromagnet. If it has current running through it, not if it just has charge on it. It has to have current. Current has to be flowing. You have to have charges moving. Oh, just okay. No, pull out. Divide by dt. What does dy dx and ddx mean? So ddx is an operator that like operates on something, whereas like dy dx tells you that you're already doing ddx onto y. This is kind of like why they write this. Am I a professor? I do teach physics at UCLA. I'm like a visiting professor or whatever you call it. All right, let's just take a look at this. I'm gonna start writing some shit down. I think I'm just gonna start substituting v in here. So I have ddt of xv, right, is equal to, and then this is x ddt dx dt. That's what d squared dt squared is. And then this is going to be plus v squared is equal to gx. Explain that one more time. Okay. So a lot of times you guys will see derivatives written this way, like dy dx, or they'll say like y prime, or you can say like y dot. All that's doing is taking an operator, ddt, and operating it on y. So usually like you'd say like, oh, if y is equal to like 3x squared plus 2, let's say 2x, right? dy dx is the same thing as doing ddx of y, which is the same thing as doing ddx of 3x squared plus 2x. And so when you operate the derivative with respect to x on this thing, you get 6x plus 2. So this is also called dy dx, right? Which I'll call y prime or something, yeah. Yeah, that's how that works. Okay, well, let's see. I think we got something close here. Because, okay, this is v, right? Okay, so now I have ddt of xv is equal to x ddt of v plus v squared and is equal to gx. All right, so, yeah, okay. Oh, and this is just the chain rule, right? This is all they just did a product rule here is all they did.
Yeah, yeah.
Yeah, right? That's just a product rule. Oh, I'm dumb. I just wrote out what the product rule is.
Huh? You done messed up, Aaron!
Yeah, right? Derivative of the first...
Yeah,
well, in this case, they did derivative of the second thing times the first. So they did ddt to this, which is the second derivative of x. Is this implicit differentiation? Kind of. And then they did, right, times the derivative of... So dx dt is just dx dt, and then times dx dt is dx dt squared. Okay. And I want to know why that turns into this. Oh, okay. So maybe instead we should plug dx dt into here. I think this looks like a little bit nicer, right? So if I do ddx of dx dt squared, right? Now this is just a chain rule, right? And then this is equal to negative 2 over x dx dt squared. Let's move all this stuff over. I don't need this anymore. Now, go somewhere else. Okay, and then this is plus 2g. But I want it to look like ddt. ddt of x dt. Or ddt of xv. Guess who's a tutor now? What's up, Machka? I hope it's you. Bum, 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 bum. Is this the same thing as integration by parts and the product rule being the same? Oh, where like one's the backwards of the other? Yeah, kind of. I think it's like we want to do a chain rule somewhere.
Yeah, I think we have to do something rewriting the
I'm gonna write the derivative as something else.
either the derivatives or the operators as something else. Yeah.
Is it like it's like dv dx, right? Is equal to like dv dt times dt dx. I don't have dt dx though. Or maybe that's what I'm supposed to do, right?
I guess you could say that what's it called? dt dt or d dt is dt dx. Or well, isn't dt dx times dt dx.
Oh, this is also equal to
Which I
is equal to ddx. Oh, okay. Oh, and that's gonna give me a 1 over v. I think probably from this, right? Okay, so you're saying I could rewrite this operator as this?
Is that whole dt dx?
Yeah. Okay.
The whole left side of that.
I see. So this is ddt. Use Schoolhouse, nice. Yeah, that's the Khan Academy one. Let me know how it goes. I don't know if like people are actually useful in that one. Tell me. Well, can I just like cancel one of these? That'd be nice.
I mean, if it works, it works.
If it works, it works. Calculus people hate this one cool trick. Oh, yeah. Well, wait a minute. But here I have ddt of x dx dt. How's that gonna work? This would get me ddt of dx dt, right? Is what dv squared dx is? Or dv squared dx. And then ddx is ddt dt dx of dx dt. So one of these cancels out. And you get this. Okay. So now this is dv dt. Okay. Okay. dv dt is equal to you're treating x and v as functions of t or v as functions of x or both. I think everything. I think
you actually can cancel one because that'll be inverse. The dt dx is the inverse of velocity and dx dt is velocity. So you could cancel one and get dt dx dt.
The question is this the same thing as... Man, I don't even know what we're trying to prove anymore. Okay, so I say dv dt is now equal to negative 2 over x. It's equal to this. Sec. And I'm trying to prove that ddt of x times v is equal to all this. I get the dv dt is acceleration. Do I want to do that? Do I want to deal with that though? I'm trying to prove that it's equivalent to this eventually. Which, okay, wait a minute. Schoolhouse is pretty...
able to try...
I think I want to rearrange this.
Through by x. Well, you could multiply that other equation through by x. I think because this equation saying the g as the acceleration due to gravity. But since we don't have any x terms, if you multiply everything through, that might get you closer.
I think what happens is I'm going to move this over. I'm going to multiply both sides by x. I think this is what's going to happen. Okay, so this is dv dt plus 2 over x dx over dt squared is equal to 2g, right? And then I'm trying to get it to look like this part, I think. I think this is what I want. I want this part to look like that. Because this is just telling me what the fucking product rule is.
The product rule, yeah.
Yeah, I'm like, great. Okay, so we're trying to get to here. So I want to multiply through by x and divide by 2. That's kind of harmful for here, though. So what? 1/2 dv dt, or it's x over 2, right? Because we're gonna multiply through by x as well.
Yeah.
Plus dx dt squared is equal to gx. Ooh, this looks very close, right?
Yeah. We might have just forgot a 2 somewhere on the dv dt, I feel like.
Right. Yeah, okay, because d squared x dt squared is dv dt. Where's my factor of 2? I'm just missing a factor of 2 somewhere. Dang. Oh, you know what? You know what it is? I think this is a chain rule. Watch this.
Oh, yeah.
Yeah. Sorry, this is all right. Let me back all this shit up real quick. I think I see it now. I don't think we wanted to do all this. I think this was a little bit much. It's okay. It's an exploration. Okay. dv squared dx is the same thing as 2 so this is okay. d dx is the same thing as d dv times dv dx, right?
Yeah.
Okay. But then this is a v squared, okay? This is where the operator comes in. Okay. Oh, no, that looks ugly. What? What are you doing? Whatever, fuck it. Okay. So watch what happens. So if I do dv squared dx, that's dv squared dv times dv dx.
Yeah.
Okay. And then from this, I'm going to get 2v. And then this is dv dx. Okay. And then here's what I think I say. I say that dv dx is the same thing as dv dt times dx dt. Right? That's that's where the factor of 2 came from. Okay. So now this whole thing is equal to 2v. Man, this really like stresses the formalism stuff of calculus. You really got to be really tricky with it. Okay. And that's all equal to the left side. Okay. So that's what this is. And then I can say, okay, well, all of that yes, sorry, I do mean
A.
Yeah, wait, one sec. I fucked this up, sorry. This is dt dx.
Oh yeah, you're right.
Right, okay. Okay, and that's all equal to, thank you, JC, by the way. Just save. Okay, that's equal to negative 2 over x v squared plus 2g, right?
Mm-hmm.
So, now, what's up, River? Okay. I'm going to move this over. And I'm going to get that 2v dv dt. dt dx. But remember that dt dx is equal to 1 over v.
Yeah.
And then I'm going to say plus 2 over x v squared is equal to 2g. Now this cancels. And I can cancel all the 2's. And so I'm left with dv dt plus v squared over x is equal to g. Now I multiply through by x. So I get x, and then dv dt is the same thing as d squared x dt squared plus v squared, which is the same thing as dx dt squared is equal to gx. And that's what this thing is. Right? Yes. Okay,
yes.
Cool, I'm gonna give myself a little like walk out there. Nice. Okay, great. Okay, so that was part 1.
Surprise, motherfucker.
How long did that take me already to do that? 24 minutes?
Surprise, motherfucker.
Took 24 minutes to do that? This book is from hell, dude. Okay.
A little bit.
Let me like come back to the rest of these parts. But that was a cool first part, yeah. Yeah?
Yeah, it was.
I'm sure you'll be around. Even if you're not,
yeah,
because then this looks like this will be fun.
Yeah,
I think this was cool. I appreciated this book has had me look at derivatives in physics in ways that I never have before. I've never even considered that dt over dx is 1 over v. I have a PhD in physics, and I've never done that. I've never been like, oh, let's just invert the derivative. It's
that's
cool.
why I hate when like they want me to focus on like analysis courses in math, because I find this shit way cooler.
Yeah, this shit is cool.
And it's way more applicable.
It is applicable. Yeah. Like, yeah, maybe I do have, a chain that I want to like determine what the equation of motion would be as it like fell down. Yeah. The falling chain and energy. It's a cool question, right? Because it relates to real life. Not like what's the residue around an imaginary pole in a hole and like
in fairness, I have used that type of stuff before, yeah, because in complex analysis you can get certain integrals like real valued integrals, and you can expand them to the complex plane and use the residue theorem to say we know what the total integral is, we know what the imaginary part is, and then use that to solve for the real part of the integral without actually solving it. Like you can do sine of x over x from negative infinity to infinity using that same
that identity
yeah.
Okay, that's kind of cool.
You find the residues and they have a value, but then the sum of your residues is the integral.
Okay, that's pretty cool.
That's dope.
All right, nice. Well, I'm gonna post this one on the channel. I was struggling at first, and I was like continually struggling through that question, but the struggle is what makes magic. And
yes,
I don't know.
It is.
I feel like I'm a better person today now because of that, So
I agree.
You. Okay. Thick. All right, there you go. Let's give him a point for that as well. I do want to come back and do the rest of the parts if we have time. We'll see. Let's go see what we got on the queue. Again, if you're watching us from TikTok, YouTube, whatever, worldwide platforms, the website to submit questions is actualofficehours.com. Right there. What if you drop your chain into a residue? You got a dirty chain, I guess. Drag your screenshot in, put your username, hit upload. It'll get submitted. And then once it does, there's this nice little live queue. And so, very cool. These are the current standings. And the solution, I think, for anything these days is gambling. Shout out Rainbet. If Rainbet wants to sponsor this stream, I think that'd be really cool. We're going to go see whose question's going to get solved right now. Spin, spin, spin. Who's going to win? Looks like it's going to be Equity. All right, Equity, let's do your question. What do we got? Ooh, fun. Rational expressions. Love this. This feels like such a softball compared to what we were just doing. What do you want me to do with this, by the way? Equity, sorry. What you gave me a bunch of rational expressions, but I don't know what to do with them. Would you like me to bake a cake with them? Let me tag them. Simplify. Yeah. Write the partial fraction decomposition. Ooh. Ooh. Okay, this is good actually. Yeah, because these are really weird partial fractions. Which one should we do first? I feel like this one is kind of easy because this is just going to break up into blah 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 over x minus 1.
Yeah, I think that would be the easiest.
Right,
You're only
yeah.
gonna have 2 factors. But
Yeah.
with
I think this one's going to be
14,
tricky.
you're gonna have 5 different fractions on that, because for each power you have to do another fraction.
Yeah, let's do that. Yeah, let's remember the rules for this. So, luckily none of these are quadratic, right? Sometimes you would get something like x squared plus 3 or something. And I think when this happens, you have to do like ax plus b. Is that correct?
Yeah, those become like ax plus b.
Right, in the form of this one. Yeah, okay. These are called
So I'd
repeated
usually
roots.
Yeah, I would cheat on those, and I would just write them as a square root of 3, so then I didn't have to do it.
You write the square root of 3? What? What do you mean?
I would rather just, yeah, I would just factor them anyway. If it was like x squared plus 3, I'd do like square root of -3.
I see.
So then I wouldn't
Oh,
have
I
to.
see. Oh, I see. Okay, so if it's x squared plus 3, you would break this into the square root of x plus 3, and then this, I don't know, the square root of x minus 3 or something? Or what?
X plus the square root of 3, x minus the square root of 3.
Oh, there you go. Sorry, that's what I meant. Yeah. Yes.
Which I don't remember if that technically was correct or not, but
Because you're solving for when this is
I
equal
was
to
lazy
0.
on my code. Yeah.
Well, actually, these are imaginary, technically. I think if you had
Oh
this
yeah,
maybe.
those would be imaginary. Yeah, if it was minus.
Okay, there you go. Okay, yeah. Never mind. All right, so let's do this. Yeah, let's do 14. So you have 6x squared plus 1, and then this is over x squared, x minus 3 squared, x minus 3 cubed. So this has a multiplicity of 2. So you have to write out all of the partial fractions up to that power, like increasing. So this would be a over x. Oh, sorry, x minus 1. Sorry, I was getting excited with the x minus 3s. All right, this is a over x plus b over x squared. And then you're going to do c over x minus 1 plus d over x minus 1 squared plus e over x minus 1 cubed. I think that's how we do this. So, yeah. These are repeated roots. When you have repeated roots, you go up to that power. So that's why this one went x minus 1 to the 1 to the 2 to the 3. And then you have a different factor for each one. Fun, fun, fun. And then this is all equal to this. Okay, great. Okay. The next step is to try you multiply this on this side. Like this gets multiplied by everything on the top. And so that this just stays as like 6x squared plus 1. And then what that's going to do is these things are going to start to eliminate stuff up top here. So I'll show the first example. So when this gets multiplied on the top, you get x squared, x minus 1 cubed times a, and then it's over x. So that single x there, right, is going to cancel out one of these. So that goes away. So that's just x to the 1. And then, for instance, the next one you would get would be same thing, x squared, x minus 1 cubed times b over x squared. But now this one would cancel out the whole x squared up here. And then this one, so again, x squared, x minus 1 cubed times c over x minus 1. Now this cancels out one of these. So then that's that. Dang, this is a huge mess, bro. Bruh. This is a mess. Okay. I'm going to simplify some stuff. So this is x squared just times a single x minus 1 times d. And And then this would be plus x squared times e. Holy shit. Okay. Well then. Your next step is to expand. This is just brutal. I don't know if there's any, like, fast way to do this one. Okay, because... Man, because I could expand x minus 1 cubed. I think that's x minus 1, and then it's x plus 1 plus 1? Is that what x minus 1 cubed is? Or it's x squared, sorry. X squared plus x plus 1. I gotta remember. Just for my own sanity. It's not 2x. I don't think it's 2x. No, it's a single. Yeah. That's what makes it different from the binomial, from the perfect square, from the difference of squares, sorry. Or the perfect square trinomial. Yeah. So, yeah. The rule to remember is, like, if this is minus, the first one's minus, and then this is plus. If this one is plus, the first one's plus, second one's minus. Okay, but then this was all still times x. Kind of the annoying thing. And that's times a. But then it's plus x squared plus x plus 1 times b. And then plus, this is x squared minus 2x plus 1 times c. Now let's think here. I think if you plug in, like, x equals 1 and x equals 0, you can start to eliminate some stuff, right? Maybe I don't want to... I want to see if there's a shortcut to this. And then this is x to the third minus x squared times d, and then plus x squared times e. This is all equal to 6x squared plus 1. Yeah, so let's think here, actually. This might help us sometimes. Let's say choose x is equal to 0. So if x equals 0, then you should get whatever's left here only equaling to 1. And so what that does is this term survives. This goes away, this goes away. This goes away, this goes away. Right? I think so. Right? Yeah. No, sorry. This term's the only term that survives. Because everything else has an x in front of it. Yeah, the first term goes away, and then I think these three go away, right? Yeah. If you choose x equals to 0, then 6 times 0 squared plus 1 is equal to b times negative 1 cubed. Oh, great. So you can get b right off the rip. Oh, yeah. It's actually kind of nice. So 1 is equal to, yeah, negative b. So b equals negative 1. Yeah, that... sorry. Wait. No, b equals negative 1, I think. Because negative 1 cubed is negative 1. And then you need something else to get you just positive 1. I think b equals negative 1. Okay, and then the other one you want to choose is choose x equals 1. So then, this dies, this dies, this dies, this dies. Right, and the only thing that's left is this one. So in that case, if x equals 1, you're going to get that 7 is equal to x squared e. Oh, but x equals 1. Oh, so 7 equals e. Yeah. This goes away, this goes away, this goes away, this one goes away. This is the only one that survives. Okay, cool. So we got 2 solutions here. We got E and B out of the way, which is nice. Because now we only have these 3 we got to deal with. The classic B and E.
Good job.
Michael, what's classic about the B and E, by the way? Sorry, what? Okay. Dun, dun. Breaking and entering. Oh, okay. I learned something about the criminal justice system today. Okay. I think the nice thing is that at least helps us out here. So I know this is -1. And I know that this is 7. But I still have like 3 other things I gotta deal with. But I only have 2 equations. I'm only gonna get 2 equations. No, I'll get 3. Because there is no x cubed. Okay. Alright, I really don't want to multiply this out. This is gonna suck. This is okay though. Let's take the wins where we can. So I have dx cubed minus dx squared plus 7x squared. That's from here, right? This is going to be x to the 4th c minus 2x to the 3rd c plus x squared c. This one's -1, so that's cool. So then I have minus x squared minus x minus 1. This is the one I'm dreading. The horror. Yeah, look at the horror. Look at the horror. Fifth order polynomial on the bottom, dude. Shout out to Zach. Zach's great. There is some horror here indeed. Okay. You're forgetting x minus 1 for the B? Am I? I am.
Yeah, I think you are, because...
You're correct. You are correct there.
Yeah.
If only it was so easy. Okay, so we actually have to get rid of this. Damn it. Alright, let me do some stuff. Alright, x minus 1 x squared x. The first 2 terms are difference of cubes. Sorry, the last 2? Where do you see difference of cubes? The last 2 factors. These are not difference of cubes. No. In term 1. In A. Yes. No. Wait. No, it wasn't a difference of cubes. This what? Oh. Ooh. Ooh, you're right. Wait. Wait, I fucked that up. Man. I'm crossing my wires. Yeah, sorry. Let's fix this. Yeah, that's wrong. Yeah, I did this wrong. Yeah, it's a 5-part partial decomposition. Someone in
I
Canada.
think that makes your B wrong as well, too.
Yep, correct.
Your value for it.
It does, it does. Okay. Perfect. Cube? Trinomial? Does that even exist? Okay. There you go. This is what I want. Binomial cube equation. Okay, thank you. Zach's got it for me as well. Nowadays, I don't care about learning computational stuff that are repetitive. I agree. This builds character, though. You know? It is the binomial expansion, which we literally did yesterday. Sorry, I'm just trying to find a screenshot that looks nice. So, yeah, actually, this is the Pascal stuff. Sorry, I was crossing my wires. This is wrong.
Surprise, motherfucker.
We do not need this. This is so wrong. Thank you. Thank you, River. Best of luck with your homework. Hopefully it's not like this. Not like this. Oh, okay. So then this isn't too bad, right? Because this is x minus 1 cubed just times x. Okay, great. Okay, so x actually makes life actually a little bit simpler. Yeah, got it. Okay. So that's going to be x to the 4th minus 3x to the 3rd plus 3x squared minus x. Okay. And then this is just a straight x minus 1 cubed. So this is just... Yeah, this is a pain in the ass, dude. X cubed minus 3x squared plus 3x minus 1. Are there... Zach, is there an easier way to do this question? This is the question. I'm curious. I'm just doing it with partial fractions. Because that's how I thought it was supposed to be done. Is there an easier way to do this? I would love to do this an easier way. Okay, here we go. Okay, ax to the 4th minus 3a x cubed plus... Oh. I see an expression with no... They want you to factor this. Or whatever, just write it into factors. Yes, correct. Okay, there we go. Oh, wait, but we know what b is. Oh, right? But b is equal to minus 1. Oh, okay. Let's okay. But so that's negative 1 cubed minus 3 minus 3 minus 1. So negative 1 minus 3 is negative 4. Minus 3 is negative 7. Minus 1 is negative 8. So that's minus 8b. Or minus 8, I think. No. Sorry. Dude, no. Sorry. B is equal to negative 1. Okay, so it's minus x cubed plus 3x squared minus 3x plus 1. There we go. Thank you. I'm getting like fucked like sideways and backwards on this question by my wires are crossing so much on this. I screwed up like difference of cubes versus like a perfect cube trinomial. And then like, am I solving for x? Am I solving for b? Okay. We're getting there. This, honestly, I would just plug into ChatGPT. I guess this is just garbage. Okay. Let's group by terms. Let me find my x to the 4ths. There's an x to 4th. There's an x to 4th. Okay. And notice how there is 0 x to the 4th plus 0. Why don't you? Because you're here, Zach. And I want to make you proud. That's why. Okay. All right. 0 x to the 4th. Okay, so 0 is equal to a plus c. That's the only thing with x to the 4th in it. Let's go hunt down our x cubes. Okay, here we go. 0. So there's 1. There's 1. There's 1. There's 1. If I ever sign this problem...
remember a way to do this as a system of equations. I think you can do it that way.
Well, yeah, once I have... Yeah. Once this is a system, this will be easy, right? I just need to write the systems. Minus 2c plus d. And then we have x squared terms. Where are my x squared terms? There we go. So that 6 is equal to 3a plus 3 plus c plus 7. It is something you have to do at least once, yes. And we are doing it once here. Okay, last one. And then 1 is equal to negative a. Oh, wait. Ooh, I fucked up. Sorry. That's 6x squared plus 1. Sorry, there's plus 0x. Oh, wow. This is... Okay, got it. Sorry. Let me fix that. Plus 0x plus 1. Okay, got it. This is 0. It's a 5-part system. Yeah. Minus a. Minus 3. Thank God for the colors. Michael says minus d. Where am I where am I missing? Oh, the minus d on the 6. Yeah, thank you. Yeah, almost forgot that one. Thank you, Michael. I did mess it up. Okay. Okay, I think we're almost there. Kids, remember, if your teacher gets mad at you, if your teacher made you do an advanced system to solve 5-part decomposition, tell them respectively no. Yeah, just tell your teacher, like, uh-oh, that's my no-no square. Don't touch me there. Like, no. I'm getting violated by this question. I don't like this. This is not enjoyable. Okay. This is 1. This is equal to 1. Wait. Okay, thank God. 1 equals 1.
That's dope.
God is not a lie. Right? Okay. That's kind of a useless part of our solution, right? Was there anything... I don't think there's any other variable that was attached to just that. Multiply by... Yes, but b was also equal to 1. Wait. Well, okay, we took care of that. There was a minus 1 here, and then there was a minus 1 in the b. B already got solved, Zach. So when we had this, yeah, I chose x was equal to 0, then I chose x was equal to 1, and I got 2 solutions. I got b and e. Okay. All right, cool. All right, yeah, so from this he is right. This is relatively simple. This is just a chain reaction. So this is a is equal to negative 3. Love it.
Good job.
And then if a equals negative 3, that tells me c is equal to 3. Gucci. Yes, Zach. Okay, and all I need is d then, right? So that's 9 minus 1 is 8. 8 minus 6 is 2, so d equals negative 2. Beautiful. All you need is D gold. Yeah, these days. There's a funny shirt because the here I'll show you. It's actually it's related. TikTok thinks I'm not human. One second, let me do that. So in Los Angeles, we have a metro line called the D line, and it's something that's been in the works for like, I don't know, like 10, 20 years, and it desperately needs to happen. LA sucks because the one area that like people need a subway is like going through Beverly Hills and other places where a bunch of rich house fucks like refuse to let a subway go underneath. But it's like, it's super, like it would connect all of LA so well. So anyways, there is this D line which is finally getting built from downtown to where I live, which is like kind of like Sawtell-ish. And they're now selling t-shirts. Ride the D. I think this is literally from like LA Metro. Yeah, here. I'll show you. Like, this is the. Okay, apparently it's a thing. Like, Metro loves it. Okay, yeah. For those that are familiar with Los Angeles, this is what they're trying to build. Can't you have better names? Yeah, I don't know. So it stops here, but then all of this is called like the West Side Corridor. This is probably the most heavily neglected public transport artery in Los Angeles. I live right here in like Sawtell, but for instance, I had to go get my hair cut. I had to go to Beverly Hills. There is no subway that goes there yet. If I wanted to go to like West Hollywood and stuff, yeah, again, there's no subway there yet. If I wanted to go downtown, I technically have to like walk here and then take this gold line in, which I do like the gold line. Oh yeah. But yeah, this whole area is incredibly wealthy and they don't want any of the construction, but the city is finally putting their foot down and being like, no, it's gonna happen. And so that's the D line. Okay, so we found out that A was -3. Okay, so your answer is Mid-Wilshire rookie. Okay, -3x plus, so minus 1 over x squared plus 3 over x minus 1 minus 2 over x minus 2 squared, x minus 1 squared, sorry, and then plus 7 over x minus 1 cubed. I think that's the final answer. Red equation checks out. We did something right. We love that. I'm gonna throw this in Gemini and just tell it to go do it. Go Clanker. Do partial decomp for this. It should work itself out. Yep, see, there's all the factors we did. Yep. Oh god. This is all I care about. Let's see, did we get the same thing? Minus 3 over x, minus 1 over x squared, 3 over x minus 1, minus 2 over x minus 1 squared plus 7. Yes! We did it. That one only took 29 minutes.
I think that took longer than the first one.
I think it did, actually.
And that was like a challenge interval problem.
Yeah, I mean, this was a very... This was just fucking brutal. It's just brutal. The only reason I stuck with it for as long as I did is because I know I can do it. And it's like going to the gym and like hopping on the treadmill. You're welcome, dude. Do you completely trust ChatGPT for every answer? No, of course not. But if I got the same thing chat got, there's a very, very slim chance that... Was it type 2 error? Yeah, there's a very slim chance that, like, we got it right, but it's actually wrong. Yeah, Michael, it's like Dr. Gold 29 minutes ago. This one is a softball. I was so wrong. I was so wrong. You know,
That's one big pile of shit.
it looked like a softball. It really did. I think.
Yeah, up until he said partial fractions.
Yeah, the partial fractions part got me. Also, I forgot how bad a fifth order one is. Okay, cool. All right, let's go spin the wheel. I don't know why my chat isn't working on TikTok. I see you, Michael, thank you, but you can't see everyone else in the other chats. I don't know why. Usually my other chats show up on TikTok. They're not showing up today. But if you ever want to watch us on all the other cool channels we have, so the website actualofficehours.com is where people are submitting their questions. You can also visit YouTube, or you can watch it on Twitch. Twitch is nice. It has a nice like horizontal format if you're on like a laptop. It's a little bit easier to see things. Maybe there's a more clever way. I don't think there is a more clever way. If you want 200,000 by 200,000 matrices, watch Dawn's. Bless Dawn. Could you have guessed? I don't think you could have guessed. I mean, what we could have done is once... Well, this is weird. I had to go all the way from here to here. If you had somehow guessed to just do this one and then do this one, then you could have skipped out doing one of the other ones. But I think you do have to like put it all out. Put it all out. Are you able to do 18? I'm gonna take a break. This took 30 minutes to do 14. This one's the same. It's the same process, but then it's 2x minus 1, 2x minus 1 squared, 2x minus 1 cubed. And I just don't want to do it. If I have time. But, yeah. Alright, let's see. What do we got? Nice. Gladiator's got one submitted. Lucky Cat, cool. Let's spin the wheel. Don't you divide to start? I don't think so. I'll take a look at it in a second. Lucky Cat, it's you. Congrats, you had a 27.9% chance of winning on that one. That's pretty cool. Ooh, see, is this a softball? Is this an actual softball? Maybe. On this,
it seems like it.
Wait, on this one, don't you need to divide? Do you have to do something weird because this is a higher power than this? I don't know.
I think you have to do like a synthetic division or a long division, I think.
Okay.
And then you can do it, but it's been a minute since I've actually had to do partial fraction.
With the power being, yeah, I don't know if I've seen this, the power being taller on the top, but yeah, I kind of like what Breasticles is saying. Like, would you divide this by maybe one of the factors? Is that what you do? Like 2x minus 1?
I think you just do the whole, like,
oh, you do the whole thing.
Yeah, I would just go about it like a normal division first.
Okay. If we have time equity, I'll take a look at this. It's also in our Discord. If anyone feels like having fun with it, it's right there. Why not do change of variables? Oh, like set u equal to 2x minus 1? I think because we're not trying to integrate or anything. You're just trying to like do partial fractions. Okay, let's see this one. Bingo. All right, let's see. Solve the inequality algebraically. This is beautiful. I love this. Okay. What you do here, Pineapple, is you're going to take every individual factor here. It's nice it's already in factored form. And you're just going to set it equal to 0. And those become like critical points. That's kind of what I like to say. So, for instance, this one, x plus 2 is equal to 0. That means x equals negative 2 is a critical point to go test. This is 2x minus 3 equals 0. So x equals 3 halves is another one. And then this is x plus 1 is equal to 0. So x is equal to negative 1. the reason why I'm going to test these points is because if this is in factored form, if either one of these three factors is equal to 0, it'll make the whole thing, right, equal to 0. And then that would satisfy this less than or equal to thing. I think these are also called like the turning points. Because when we say this whole thing comes out to be like x cubed plus x squared plus blah, 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 with different factors on it. And that would end up being a graph, right? Which would, they're all positive, right? So, I don't know, probably something like this, right? And so when they say less than or equal to 0, what we're doing is we're finding where these roots are. And then we're going to test, oh, okay, so between negative infinity and this root, right? So where this whole thing is equal to 0, are we below or are we above? I think just by looking at this, because you know this is a positive, notice how all the first terms are positive. You know this is an odd function. You know it's positive, and you know it has 3 roots. So this is already the shape of it. So I think I can guess that between these 2 roots, it'll be less than or equal to 0. And then from negative infinity to the first root, it'll be less than or equal to 0. I think I can just do that right off the bat. And right, and the roots are distinct. If any of these were like squared or like whatever, then you could get like bouncing. But they have to cross everywhere, yeah. So let's see. Let me just guess. I'm going to guess. And then we'll check. So my guess is, so arranging these roots, so this is the furthest left. This is the middle one. This is the furthest right. I would say from negative infinity to negative 2, bracket, and then union, I think, negative 1 to 3/2. I'm not really guessing. It's like educated guessing. Yeah, I think that's one. But they want like a chart. So I'll show you what they actually want. This is like the smarter way to do it if you understand math on a more holistic level. But if you want to do it with the number line technique, which I think is what they want, you're going to like plot these as points. So I can say this. So we got like 3 points. I think this is the chart they want. So for instance, this is negative 2. This is negative 1. This is 3/2. And then what our job is to pick, because then this represents like negative infinity over here. And then this represents positive infinity to the right. What's up, Serenely? So we're going to check the regions. Holistic gold. Okay. So we want something that's less than negative 2. Let's just pick negative 3. I want something between negative 1 and negative 2. I could say like negative 3/2. I want something between negative 1 and 3/2. I always like to pick 0 somehow. 0's dope.
That's dope.
And then greater than 3/2. Why not 2? Okay. So then your job is like plug these test points into here and see what happens. And in this case, you don't even have to figure out what the numbers are. You just have to figure out like positive, negative. So for instance, when I plug in negative 3, negative 3 plus 2 is going to... I'm not even going to worry about what the number is. I'm just going to say, well, negative 3 plus 2 is negative. Okay? If I plug it into here, I get negative 6 minus 9. That's also a negative number. And then if I plug negative 3 into here, that's negative 3 plus 1, negative 2. That's also another negative. So now the question is, a negative times a negative times a negative is what? Well, negative times a negative is a positive. And then a positive times a negative is another negative. Is a negative less than 0? It is. So this is a check mark. So then you go check the other ones. Crazy Run says, I found this really cool way to decompose 1 over 1 plus x to the 4th, but it doesn't fit on one page. Oh dear. So, negative 3/2.
I think that was a joke. I forgot what the proof was, but there was this one proof. Like they took years figuring it out up until like the 2000s. And I guess the dude who had originally proposed it, he was like, yeah, I got a proof. And it proves it perfectly. Yeah, from Fermat's last theorem. And he was like...
Oh, Fermat's last theorem. Yeah.
Yeah, but he was like, doesn't all fit in the page. And then he died, and no one could figure it out for...
No, but someone has done it. Fermat's last theorem has definitely been done. Oh,
Yeah,
Fermat said...
but it was...
Oh,
Yeah,
when
he
Fermat
said
did
it.
it. Oh,
Yeah,
what a
he was
bastard.
like, I know the proof, but can't fit it in the margin.
Oh, that's hilarious,
It
dude.
took up until like
That's cheeky.
relatively recently to figure it out. or to
Yeah,
prove it.
Wiles did it. I remember there was a big documentary about it. He also like lost his wife and family doing it. Like she straight up divorced him because he just became so enamored in the math.
Which is why I don't do proofs.
Yeah, don't do proofs. He'll lose your family. Would you rather have a derivative son or an integral daughter? Dude, what?
Easy, integral daughter. Derivatives are overrated.
Derivatives are overrated.
Integrals are cooler.
Integrals are cooler. Yeah. I think derivatives are pretty easy to solve though sometimes. Integrals have more complexities for sure. I use integrals to check my derivatives. Yeah, bro was lost in the sauce. Imagine that, dude. He sacrificed everything to solve that. I hope he got some money out of it. Alright, negative 3/2 plus 2. Well, that's positive. So negative 1.5 plus 2 is positive. This becomes negative 3 minus 3. That's negative 6. That's negative. And then negative 1.5 plus 1 is also negative. Look what happens. Positive times a negative is a negative. And then negative times a negative is a positive. Is a positive less than 0? Nope. So that's why that's that. You can check 0. So it's positive, negative, positive. That is negative. So that's good. Then you can check 2. Positive, positive, positive. Is that less than 0? No. Nope. So that's a no. And turns out we were correct. Negative infinity to negative 2. And then negative 1 to 3/2. Great job, everybody. Again, you could have just solved that from some cool intuition here. But I think this is the way your teacher wants you to do it. Hope both make sense. Finally, a softball. Yeah. Do you have to list it? So, yeah, when you want to list the intervals... Oh, do you have to list, like, plus, minus, plus? I mean, that depends how much your teacher wants you to show your work. I guess you should, maybe. I think this is probably good enough. But if they actually want you to do it, you could say, like, for instance, this would have been, like, you know, for x equals 2, and then just show, like, positive, 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 and positive is less than or equal to 0 is, like, no. I think that's kind of enough work if you want to. Cool question, though. Interval notation is goated. Truth. Okay, what's up? What do you want to
Step builder is better.
Step builder is better? What is that?
No, set builder.
Oh, set builder. Oh, like set notation.
Yeah, I prefer that.
Yeah, set
It's
notation's
cooler.
pretty dope. Yeah. Zach taught me how to read set notation. Thank you, Zach. Alright, one sec. You want me to check this real quick for you? I finished, but it's good. The remainder is form 4. Show your process. Oh. Yeah, so, this just means that f of 1 is equal to 4, right? So k plus 1 equals 4. Dude, your handwriting, dude. What is this, bro? Is this a K? What is this, dog?
You should see mine. My X's look like alphas half the time.
Oh no, no, guys, no.
I don't pick up my hand when I write the 2 lines when I get lazy.
Do you know how like Taylor Swift like holds a pen?
I've never seen her.
Oh, she's crazy. One sec.
Like, bro.
Taylor Swift holds a pen. Yeah, dude. What is this? What is this abomination? What? Who saw through the what? Dude, what? What is this?
They used to make kids who wrote like that in high school. They used to make them take like handwriting classes and spend hours fixing it.
GameCube controller claw grip.
Surprise, motherfucker.
It's just no one taught her how to hold a pen. Anyways, sorry. The remainder is 4. So I think like f of 1 has to equal 4 is what that means. Right? Yeah. And did you show that? So 1 plus 1 plus 1 minus 1. So minus 1 cancels. So 4 equals k plus 1. So k equals 3. Yeah. I think that's good. It's super effective, Costa said. Really? Like holding the pen like this? This is super effective? No.
Lies.
No, dude. I feel like a caveman. Dude, what? That pen handling is brilliant.
No, it's not.
Dude, why does Reddit make it so hard to like view their images? Yeah. I don't know. Dude, what's 6 here? Sorry, she holds it between her index and her middle. Nope, that's not it, chat. I'm sorry. Not it. Ultra high IQ move. Okay. All right. That's a point for Lucky. Let's see who's gonna get the next question. One has a 75% chance of winning. Let's see. You would think 1 would win at this point. Kind of have to, right? Yeah. You like dominate the cube right now. All right, good job. The gambling gods have. Ooh, rationalized the numerator. I kind of like these. Are these softballs? Do we get some softballs, chat, finally?
Yeah, they are.
Okay, these are softballs. Thank you. Okay. Isn't this already rationalized? Am I crazy?
No, I think they mean right. So you would just multiply by the conjugate.
Why do I want the numerator to? Yeah, okay. That's why I'm getting screwed up with. Jeff's like, yeah, you usually rationalize the denominator.
Yeah.
1K says, Gold, my teacher has been away teaching girls hockey for 3 days while we're learning by ourselves. What's funny is the dude has a beer belly and can't run. I mean, bro, have you seen the Chiefs head coach, dude? What's that guy's name? Andy Reid. Yeah. Yeah, most coaches aren't really athletic. Yeah, I don't think Andy Reid can play very good. He's a master fucking head coach, though. So, yeah. Rationalize the numerator. Okay, yeah, okay. So, rationalize the numerator. Yeah, that just means multiply by the conjugate. So, multiply by conjugate. Conjugate's a fun word you're going to see a lot in like complex analysis, like the conjugate. Complex conjugate, right? Okay. Conjugate to this, if it's a minus, it's a plus. And you have to do the same to the top and the bottom. And what that gets you, because you have a minus b being multiplied by a plus b, gets you a squared minus b squared. So you end up getting 1 squared minus the square root of 5 squared is all over 3 times 1 plus the square root of 5. Well, this, so square root of 5 squared is just 5. So that's 1 minus 5. And then we can say over 3 plus 3 square root of 5. So then it equals negative 4 over 3 plus 3 square root of 5. Teacher be trolling. Yeah, right? I don't know. It's kind of weird. Dude, like, what's going on here? Yeah, let's try this one. I'm going to skip these because I feel like it's the same technique. You know what to do. Well, let's try this. Okay. So that would be the square root of x plus the square root of x plus h. So someone told me in the chat, Equity, that sometimes we rationalize the numerator for integrals. Integrals are easier to do when the numerator, I guess, is rationalized. I'd be curious to see an example.
Yeah, I guess so. Well, I guess if you do it that way, you could probably get like a
arctangent or something.
Yeah, like an arctangent or something like that. Maybe.
Oh, it says it's useful to rationalize the numerator to find the limit when it's an indeterminate form. I see. Yeah, because then it's like 1 over something basically. Maybe. Hopefully. Well, let's see what's happening here. So we multiply by the conjugate, so that becomes this thing squared minus this thing squared. This is just a mess. I'm going to leave it like this for now. And then it's because dude, it looks so ugly. Yeah, that's why my teacher reviews this when we learn limits. Okay. The cool thing here, right, is this becomes x squared minus h squared. Tricky thing here. Remember this minus sign hits both things once they come out of the radical. Okay, but x squared minus x squared is 0. No. Beautiful. So then I have over this hot garbage. So then the nice thing is I can at least cancel one of these with this. And I'm left with minus h over this times this. So that's going to be the square root of x squared plus xh times the square root of x plus square root of x plus h. I don't know. Do you think the teacher wants us to, like, foil this through? So square root of x equals x, not x squared. Oh, I fucked up.
Oh shit, not good.
Yeah, my bad, dog. It's the same thing, though. There we go. Oh, wow. I had an absolute stroke of a moment there. Sorry, my bad. Sorry, square root of x squared is x. Yes. Okay. This goes away. This goes away. This cancels with this. Okay, so now we just have negative 1. Oh, actually, okay, this is a lot easier. Thank you, Volcanic Storm. Bless you.
Good job.
Thank you for keeping that straight. Okay, this is square root of x, and then square root of x plus h. Oh, that's actually really cool, actually. Watch what happens. So these two things will multiply in on each one. Love from India. Thank you, dude. Thank you, beta. I learned beta is how they say, like, bro over there. There it's like bro. Okay, so square root of x times square root of x gets you x. So then you get x square root of x plus h. Tuma says beta.
Oh, yeah.
Yeah, right? Beta. And then this one kills this one off. So then I have x plus h times square root of x. And I don't know. I feel like that's simplified enough. It means son in Hindi. Yeah, like bro, right? Oh, well, I guess bro is different than son, but yeah. Is it kind of like, so like in Romance languages, so for instance, in Italian, if you want to say like, what's up, like dude or something, you say zio, which means uncle, technically, in Italian. So it's calling people like uncle is kind of like big dog. The square root of x is absolute value of x, not x. Okay. Well, whatever. It kind of cancels out, right? Absolute value of x minus absolute value of x still kills out. Unk. There we go. What up, Unk? What's up, Fanatic? Okay, I think this is simplified enough. I don't really know what else we can do. I think. Yeah, I'm gonna say it is. All right, that was horrendous. All right, rationalize the numerator. So I guess you got to pretend this is over 1. And then this is square root of x plus 1 plus square root of x over square root of x plus 1 plus square root of x. I'm going to do this correctly. This just becomes x plus 1 minus x over the square root of x plus 1 plus x. X minus x cancels. You're left with 1 over x plus the square root of x plus 1. Nice. Good. Cool. Thank you, 1, for that question. Very interesting. Oh, I forgot the square root of x. Thank you, Beta. There we go. Thank you. There was a much easier way to do that. What was the easier way? Using the fact that 1 over x is an involution of itself, self-inverse, write the expression as 1 over 1 over u. Oh. Oh. Wait, would that have worked? Technically oh, I see. Okay, I see. You're saying that a can also be written as 1 over 1 over a. So this would be the same as 1 over 1 over the square root of x plus 1 minus the square root of x. Okay, yeah, I guess technically that works. The Q looks so good, yeah. Yeah. Oh, Tuma, have you not seen this before? Have you not seen the new Q? Yeah, it's gambling now. Okay. So Gladiator submitted 30 minutes ago. Willie's 20, 11. There's JHNat. Let's go gambling. Who's it gonna be? I vibe coded this whole thing in an afternoon. Nice. Willie Manilli. Oh, Jesus Christ. Yeah, that's a good question. So there's a couple things that make you have a better chance for getting picked. So waiting longer, for sure. Also, you can upvote things. So if you like somebody's question, you can click upvote, and it'll boost the number of votes they have. But you can only do that once every 3 minutes. So that boosts the chance. Willie Manilli, I hardly silly. Okay. Anytime I see x squared minus 16 squared, I think I want to use like sine. Right?
Yeah, this is an inverse trig integral. I just forget which one.
Yeah, which one is it? I think it's secant. Well, let's think through this. So when you have like 1 plus tangent squared is equal to secant squared of x, then secant squared of x minus 1 is equal to tangent squared, right? So yeah, I think you want. Okay, so first of all, we gotta pull the 16 out somewhere, right? So I think I want to say that x is equal to 4 secant of u. Right. So yeah, here's the thing, Tuma. Every question has like a global cooldown on it. I used to have it then. Yeah, it's not per person anymore. It's per question. It used to be per person, but then Breasticles and other people found ways to hack it.
Bing bang.
So I had to change it.
It's not a hack. If
it is a hack.
If your vibe code didn't differentiate different browsers, that's not hacking. It's exploiting.
It's an exploit. It's an exploit. It's an exploit. It's an exploit. It's a day 0 exploit. Yes. There you go. Good job. All right. X is equal to 4 secant u. So then dx is equal to 4 secant u tan u du. I think this is the thing I want to use. Why'd you do it? Not enough knowledge on the internet? Nice. I don't know. It's a work in progress. That's just like my first solution to make the voting a little fairer. Thanks for the follow, by the way, RM1.
Good job.
Jeff, it's not different IPs, but each browser has a different port address. So while it had the same IP, it was reading the full IP and the port.
Oh.
So a different browser was a different IP according to it because it wasn't.
Wait, everything doesn't just go through port 80? Like what? Really?
Yeah, I think every browser has a different port. I'm pretty sure.
No way. Yeah, the global chat's fucked up. One sec, let me fix that for you. I don't know why it's doing it. It screws up sometimes, dude. It's annoying. Let me pull up the chat. I don't know why it's not working. It's because what is it? This is what I want. Oh, it's because of the SSL? Really? I don't really care about the SSL. Just give me this. Oh, fast. One sec. Let me fix that, actually. It's weird. Where's my chat?
I don't think you get new port numbers, Jeff, per browser. I think. But I know, like, when I would jump between Edge and Mozilla or Opera or Chrome, it would.
Dude, how many browsers? Wait, how many browsers?
Everyone.
How many browsers do you have?
I think like 3 or 4.
Wow.
Maybe 5. I had a lot more on my old PC, but I never transferred them over.
Let me see. Link. Let me see if this works. Oh, it does work. What the hell? Yeah. See, okay. Custom revolution. I think I need to make the height here equal to 275. We'll see if the chat comes in.
Yeah, I'm not sure, Jeff. I just know that even if I closed it and reopened
it was just working. Yeah, it just worked for whatever reason.
Well, if I closed it and I reopened it, it would give me the timer. But if I jumped between different browsers, it wouldn't.
Yeah. Okay. Let me try to do this one. I don't know. TikTok is weird. I hate their streaming software. I wish they would just let me use OBS, but they don't give out stream keys to people. It's annoying. Okay, 16 secant squared u from here, right? Then minus 16. Then dx, right? Yeah, isn't it ridiculous? Come on. TikTok, give me a stream key. That's all I want. I hate using their software because it just breaks half the time. Yeah. No, I agree. Jeff, if you want to take a look at it, I can add you to the GitHub repo if you want to take a look at it. I just switched it, but whatever. Yeah. Okay, this is what we got. Yeah, mega streamers. Maybe I gotta show more feet. I don't know. Okay. Right off the bat, I see some stuff canceling, right? Secant's gonna cancel at least one of the secants. This part right here is going to be 4 square root of tangent squared u. So that's equal to 4 tan u. Oh, this is super cool, actually. Okay, so I have, look at this, 4 tan u du over 16 secant u, and then there's another 4 tan u. This is actually really cool. These cancel. Beautiful. All I want for my stream anniversary is my stream key. Yeah. Come on, TikTok. It's just annoying because like just random stuff will just not work. And I guess I could restart the stream maybe to see if I could get it fixed. But like OBS I know works. Okay, 16 secant U. Oh, beautiful. But what is secant? Secant is 1 over cosine. So this is 1 over 16. Integral of cosine U du. So that's equal to 1 over 16 sine U plus C.
Disqualified.
And then we got to do a little bit of a conversion here. But we said that secant of U is equal to x over 4. Yeah, wait, why is it saying invalid security token? Yeah. Try it on a different browser, maybe.
Yeah, it does that to me when I'm using it on Edge. So you gotta go to like Mozilla or Chrome.
That's another thing for me to fix. All right, cool. I'll give you the GitHub. Yeah. Trig power. Yeah. The trig power notation. Yeah. Right, secant of U is equal to x over 4. So then you draw a little triangle. Happy triangles here. Okay, send me a DM, Jeff, with it, so I know who it is, and then I'll remember it, and I'll add you to the repo. You too, Zach. I know you were also curious about it, or anybody else who's curious, and I like kind of trust. Breasticles, you broke it the first time, so I trust you. If anyone wants to look at the GitHub, they can. Secant is 1 over cosine. So that's hypotenuse over adjacent. So x over 4. This is angle U. So then this is the square root of... man, what is that? 16 plus x? No. X plus 6, x minus 16. Opera works? Okay. Good to know. Okay. So that's 1 over 16, and then the sine of this angle is now opposite over hypotenuse. So that's going to be square root of x minus 16 over square root of x. Or I guess that's 1 over 16 square root of 1 minus 16 over x? Looks kind of weird. Oh, it's x squared minus 16. Thank you. I fucked that up. Wait, what am I doing? Sorry. Wait. Let's fix this. Sorry. 1/16 square root of x squared minus 16 over x. Thank you, Crazy Run. Yep. So that's equal to... so it's still equal to the same thing. 1 over 16 square root of 1 minus 16 over x squared. Phobos roasted my code on stream. Yeah. So here's how the votes work, Tuma. You get 10 votes when you submit your question. You get 2 votes for every minute that the question's in the queue. And then every upvote you do, which is every 3 minutes, logarithmically multiplies it by something. Why are you using PHP? I don't know. It's just simple. I originally wrote that code kind of by hand, and I understand PHP, so I kept it in PHP. Also, it's on a really old Linux server that only, I think it's like Debian 8 or something. So I have to write it in PHP 5.6. You're starting to move away from PHP? Yeah, I understand PHP. Okay. I think this is correct. This was yours, Willie. Yeah, dude, it's super old. Yeah, so even when I have like ChatGPT and Codex go at it, I tell it that I need this written in like 5.6 compatible PHP. I have so much stuff on that server, on that Linux server, so much other stuff that's like really old. and I don't want to upgrade the server because it'll break everything. So I may just buy a new server to just put this stuff on. Okay, let's see. I think we got the right answer. The triangle was the hardest part for a lot of people when they started doing trig sub. It's logarithmic. Yeah, it's logarithmic. Okay. I think this is the same answer we got. Yeah, cool. Oh, plus C. Don't forget plus C.
You're not that guy, pal. Trust me. You're not that guy.
Anyways, nice. Good job.
Good job. Well done.
Willy-nilly. Good job. That was fun. It was a nice stroll through trig subland. Yeah, the what is it? If I go to GitHub, can I log into GitHub here? Repos. Yeah. Here, I'll add it. I'll add you to it, Jeff. Groovy Jeff. How do I add you to a repo? I don't know. Settings, maybe? I don't know. Collaborators. There we go. Ugh. I don't know what this code is. Is this an authenticator code? Okay. I'll do this later. I have to go get my 2FA thing. I don't have it with me. But I will add you. I will add you, Jeff. Someone was asking about the... Yeah, someone was asking about how the math works. Yeah, so if you go into the README, this should have the math for how the logic is applied. This is it. And then, yeah, so... So, yeah, it's 10 votes to start, and then it's your age that the vote has been in the queue times 2. And then there's a boost that's equal to 1 plus the log of 1 plus the number of upvotes. Oh, you want to see how I determine unique accesses before changing it? I might not have that in the GitHub. But I can probably find a previous version of it, maybe. I think I started putting it on GitHub maybe after I did the update to individual questions. I'll check. It's in the history there somewhere. I only just got GitHub this week. I'm becoming an actual developer. But I'll check. I have old versions of it somewhere, Jeff, for sure. I just have to go find my API keys, which are also hidden in those. Okay, let's see. Who's next? Let's choose a winner. Spin, spin, spin. Who's gonna win? Gladiator's got a great chance. Nice. Crazy Run Fam. Here's my GitHub. Yeah, if you want my GitHub, I don't know, where is it? Nothing's public right now, though, is the issue. Everything's private. But there's my GitHub. Okay, let's go find it. So Crazy Run says, for my integral, I got stuck after doing substitution. All right, let's see what you got. Oh, this is a fun one, I think. Oh, dude, where's my... Wait, what? Oh. There we go. Okay, there we go. All right, let's do it. Okay, we're trying to integrate this. This looks kind of messy. I would agree that usually if you have 1 over 1 plus x squared, you want to use tangent, right? Again, for this reason. 1 plus tangent squared of x is equal to secant squared of x. That would fix that,
right?
Right?
You secant up top.
Okay, so let's say x is equal to tan u. So then dx is equal to secant squared u du, right? So then you get integral square root of secant squared u du all over 1 plus 2 tangent squared u. AFG says easy. Is it easy? All right, we'll see. Okay, so this is just a secant of u. So now I have secant to the third of u du over 1 plus 2 tangent squared u. You got stuck here. That's okay. I'm tempted to put everything in terms of sines and cosines, but probably not.
You could. No, I would recognize that your tangent squared of u is equal to your secant squared minus 1, and then you can get it.
Oh, we'll get rid of this.
Of secants.
Yeah, that's actually really smart. Okay. So, yeah, that's what Breskel said. So Breskel said because of this identity, right, you can also say that secant squared of x minus 1 is equal to tangent squared of x. So this is... Maybe it's easy peasy, lemon squeezy, whatever. I didn't see that, so I don't know. So it's 1 plus 2, and then this is secant squared of u minus 1, right?
Yeah.
Okay. Cool. Okay, so then we get secant cubed u du over... Well, this is 1 minus 2, so that's negative 1. So then I have 2 secant squared u minus 1. Partial fractions. Perhaps multiplied by cosine squared. I could kind of see... I always do like writing things as just sines and cosines. Yeah, well, let's try this. So, we know that secant is equal to 1 over cosine, right? So let's multiply both sides by cosine squared of u. Top and bottom, right? So that's going to give me a single secant. So I get secant u du. And then this is going to give me 2 minus... Was this just me the same fucking shit we had? No, right? 2 minus secant squared of u, right?
I think it simplifies if you write it in terms of
sines and cosines.
Cosines, yeah, as 1 over cosine instead of multiplying. If you just were to write it as
like that,
1 over cosine cubed, and then 2 cosine squared, or 2 1 over cosine squared.
Okay, let's try that. Okay, so 1 over cosine cubed of u du over, and then this is 2 over cosine squared of u minus 1, right? Oh, and then the cosine cubed comes down. Oh, beautiful.
Yeah.
I like that. So then that's du over 2 cosine of u minus cosine cubed of u, right?
Yeah.
Ooh.
And then I think from there, if you factor out a 1 over cosine from that again, that becomes secant on top, and then...
So this is 1 over cosine of u.
Substitution.
And then this is 1 over 2 minus cosine squared u.
Yeah.
Right? Du. But now what? Okay. This is secant then. Okay. And then what am I going to do here, we think? 2 plus cosine, 2 minus cosine? Do we want to do partial fractions? Can you do partial fractions with trig?
I'm sure you can, but...
Split the 2. That does seem to happen at times. Okay, let's do it. Yeah, when in doubt, split it. So this is the same thing as 1 over 1 plus 1 minus cosine squared of u. Right, 2 is the same thing as 1 plus 1. Oh, Willie, no, we did yours. Willie, this was yours, right? I think we got this one for you. It's in the Discord. Yeah, it's a different integral. Okay, so then this is sine squared. And then we have 1 over 1 plus sine squared u. Yes, I will ping you. Substitute y equals sine u. Okay, let's do it again. Okay, here we go. Let y equal to sine u. Then dy is equal to cosine u du. Oh, beautiful. Look at this. Oh, actually, no. Yeah, look. Wait. It's close, Zach, right? I want du over cosine. Can't write dy as a denominator. Yeah, I know. Yeah.
Well, I think you can do something with the if you put in the cosine of, you write, if you say y and then you get dy equals cosine of u du, you would get another cosine squared of u, and then you could get it all in terms of sine.
Okay, well, let's see. Okay. So y equals sine u, and then dy is equal to cosine u du, right? So then du is equal to dy over cosine of u, right?
Yeah.
So then I have the integral of 1 over cosine squared u, 1 over 1 plus y squared dy. This is kind of an issue, though. Oh, wait a minute. Cosine squared is the same.
That would be 1 minus
beautiful
sine
right
squared of u, which
that's
gets you
1
minus y squared.
1 minus sine squared of u. Okay. Dude, this is such a roundabout thing. I wonder if this is working. Right? Okay, so then this is the integral of 1 over 1 minus y squared, 1 plus y squared dy.
Yeah.
Okay, scroll up to the original. Yeah, sorry. Here's the original thing. Also, anytime anyone wants the original question, if you go to our queue here, and you type in wherever it is, you can still click on their username. If you click on their username, it'll pop out what the original question was. Yeah, you're good. How do you plug the dy in? Okay, so here's what we did. We set okay, if y is equal to sine u, dy is cosine u du. So then du is dy over cosine u. So you can literally just take this and you can plug it in. You are correct that you usually need that to cancel out. in this case, and it's only like when we do the integral. As it stands right now, I can't do this integral.
No.
You can't do an integral with respect to dy when you still have things in terms of u. But after plugging in du is equal to dy over cosine u, that bumped this up to a cosine squared, which I could then write as 1 minus sine squared, and then sine squared of u is y squared. And so that's why we get to here. Yes, exactly. So now it's the integral dy 1 minus y to the 4th. I don't know what this is. I hope it's just something nice. You can do partial fractions.
I think you would do partial fractions. Yeah, partial fractions would probably be the easiest way when you write, because 1 minus y squared is going to get you a hyperbolic arctangent, and 1 plus y squared is going to get you an arctangent.
Sure. So this is dy 1 minus y squared 1 plus y squared. Yeah, but then like, what is that? What are the constants? Is it like 1 and is it 1 and minus 1?
Probably. It's probably gonna be something like that.
Let's just see. Actually, you know what we can do? Let's just have. I want chat to try to do this just from the beginning. I want to see what it tried to do.
When I plugged it in the chat, I got it wrong.
You got it wrong? We'll see.
Yeah, well, it's right now. I got it to where we're at now, but it had done it, but it had just like
here. It gets to 1. It gets to 1 minus u
squared.
This one gets to 1 minus u to the 4th.
Oh, it does.
Okay.
Yeah.
And then go back.
It does the
okay.
decomposition.
Yeah, so I remember wondering about this, like, what's the easy one? Okay, in this case, it's 1 and 1. 1 equals 1/2 over 1 minus y squared plus 1 plus y squared? 1 equals that? Yes,
yeah,
that's
that
true.
Would be for the decomposition.
Oh, yeah, for the partial fractions. Yeah. Okay. I'm just gonna.
I think that works crazy. You might have to factor out though, because there's the 1 minus y squared is reducible technically.
Oh, to 1 plus y, 1 minus y.
Yeah, but then you inevitably get 2 logarithmic terms that
Eventually, yeah, ln and ln
arctangent,
eventually just turn into arctan or arc hyperbolic tan. Okay. Right, we get this. Awesome. And then you have to remember what fucking everything was. So y was equal to sine of u. Well, they use u here, but this needs to be y. Okay. So pretend. Yeah, it does decrease the quadratics. But what they're saying, what Brescals is saying, those quadratics eventually, you're gonna get like some ln terms, which gets your the arctangent. Like, yes, you can break this up into 1 plus y, 1 minus y, right? And you'll end up getting 1 over 1 plus y, 1 over 1 minus y, but then those are ln's. And then this is the arctangent, and then the one with the ln's is the arctangent. And then, yeah, it's just trig sub. Trig sub after the quadratic? Yeah. I don't think this is trig sub. Well, I guess this is technically trig sub. Sorry. They are known identities. Okay. So, alright. So what is it? It was 1/2 tangent -1 of y plus arctan of y. Yes. And then at this point, now you're just plugging everything back in. So then that's sine. So 1/2 tangent -1 of like sine of u plus tangent -1 of sine of u, which this is just plugging in trig. And then what was the final thing? And then u is equal tangent of u is equal to x. And then x equals tangent of u. Or u equals arctangent of x. So I don't know. This is just messy as fuck. All right, I'm just stealing it. I'm stealing it. There you go. I just want to keep doing it. Yes. There you go. Eventually you get to this. You just have to build triangles for this, right? You just have to be like, oh, okay, well, if arctangent sine of u. Wait, how do you do arctangent of sine of u? So this is the
I would
angle.
probably just do 2 triangles. If you start with your x equals tangent of u, you'll figure out. But
I like that better, right? If this, if tangent u is equal to x, right? Okay, okay.
Sine.
I got it. This is u, and then tangent is opposite over adjacent. So this is x1. This is square root of 1 plus x squared. Oh, bingo. Okay. So then the sine of u is that over that. Okay, cool. That's where that comes from. Yeah, okay, much better. I was looking at this. I was like, what the hell? And then, yeah. Okay, same thing. Cool. Yeah. U over 1 plus u squared. Okay, cool. Nice. No, you're not stupid for getting stuck. This was a lot. But we did get there eventually. Thank you, everyone in chat. Y'all are all great. Crazy run fan. Nice. I'm gonna mark that as done, and I'm gonna go put it in our Discord. Just make sure go follow us on all the things. This one will get put in as a solution. Was that a Calculus 3 question? No, it's probably Calc 2, honestly.
Yeah, that would be Calc 2.
That's Calc 2. I mean, it's kind of a mess of a Calc 2 question. Alright, I got 11 minutes left. Oh, I'm getting tired. Let's spin. Oh, it already picked you, Gladiator, apparently. But let's have the animation happen anyways. I think sometimes it lags, like whether to show the thing or not. Okay, nice. Gladiator. Gladiator submitted 66 minutes ago. I'm glad we're going to get yours picked, at least. Ooh, okay. Is this a softball? We've had a lot of heaters today, dude.
Disqualified.
We've had a lot of heater questions. Oh, HNAT, yours is the answer to 18. Okay, I appreciate HNAT. I see. You did. Oh, beautiful. Oh, thank you. Oh, this is the long division and everything? Very cool. Here, I'm going to post that for Equity. Equity, by the way. I'll tag him. Thank you, JSnap. I let him know. Collaboration. We love it. You figured out how to do it? Okay, well, let's see real quick. Y is equal to f of this, and f prime of 5 is equal to -2. Oh, okay. Find dy dx. So dy dx is another fancy. They want to know what is f prime of 4. Oh, wait, no. Oh, okay. Dy dx is d dx of f of... Wait, what the fuck? Wait, what? What? Y equals f of square root of x. What's going on here? It's a chain rule? Yeah. Okay. Just chain rule blood? Yeah, figured it out. Okay. My last 2 brain cells are fighting. Okay. So this is equal to f prime of square root of x squared plus 9, right? I think so. right? And then times 1/2 x squared plus 9 to the negative 1/2 times 2x. Is that all right? Uh-huh. Okay. But when x equals 4... Oh, okay. And at x... Some people, like, think, oh, let me plug in first. No, can't do that. Always do derivative things first and then plug in the x value. So this is f prime of... Oh, the square root of 25. Oh, nice, that is 5. Times 1/2. And then this is 16 plus 9 to the negative 1/2. 2 times 4. So this is f prime of 5 times 8/2 is 4. And then this is 1 over the square root of 25. And f prime of 5 is negative 2. So you get negative 2 times 4 all over 5. Should be negative 8/5. Did I fuck up?
It seems correct.
We need chain rule. We want chain rule. Did I do that right? I think I did it right.
Crazy to check out the first problem we did today. That had a lot of chain rule.
Oh my god, yeah. Dude, reminder to what we started off like 2.5 hours ago. Me just getting like absolutely wrecked trying to do the chain rule here. We were showing that this was equivalent to this. And we did like some mind-bending things here where I was like, oh, well, dt dx is the same as 1 over v. And then ddx is the same thing as ddv dv dx. This was the chain rule. This was
it was a... Never use a chain rule like that, but it was a chain rule.
We did use it. With all that chain rule, I'll definitely function well enough to compose myself.
That's dope.
Oh, I love that joke. That's a great joke. It's a great joke there. Solid dad math joke. Okay, cool. Nice, great. This was Gladiator.
Well done. Well
I have time probably for one more. Alright, let's mark that as done. Okay.
I'm pretty sure I've seen the integral Red Roach just put in the challenge book. That
the one with the LNs?
Yeah.
ln of x to the fourth?
It's a famous.
It's a famous, like, it'll wreck you.
No, I don't know, like famous technique, I think, if I remember correctly. But it's been a minute.
Okay. JHNat, yours was just a solution. Okay, so we can just like post yours. So that's cool. We'll just post that. So then the final vote will be 100% chance. Yeah, let's see how it handles 100% chance. I'm actually curious. We need edge cases. Is this still gonna spin it? That's kind of fun. Alright, Tuma, we're doing yours now. Yay, Tuma! You had a 100% chance of winning. Okay, let's see what Tuma's got. Ooh, Volumes of Revolution. Great. I have videos on these. We're revolving around the y-axis. Ooh. I'm guessing we want to do... What's up? You guys want to come speak? Whole gang's here. Do you want... I think we want the shell method for this one. Usually when you do vertical axes of revolution, use the shell method. Yeah?
Oh, this one?
Yeah, I think we want the shell method.
Shell method, yeah.
I would be fine to do anyone.
Okay, let's do the shell method. Just in general, like if you ever have vertical axes of revolutions, you kind of want to do the shell method, which means we're going to build like a bunch of cylinders.
How do you know which one to use though?
So yeah, okay, so I'll do both. I'll show you both, and I'll show you like why one is easier than the other one.
Okay.
Okay, so this right here would be, if I could fucking get my things to look correct, right? This would be the shell method, which is we're building a bunch of like cylinders, and they're like expanding outwards. And so, shell method, if we're expanding out this way, that's going to be dx, and then that's going to go from 0 to 7.
Right.
And then you need what the surface area of that cylinder is as it expands outwards. And so that's going to be 2 pi. And then we say like r times h. Now r is always like the radius of this cylinder, which in this case is also like, because the axis of rotation is right here, the distance from the axis of rotation is literally just x. Okay. And then I got to ask myself, okay, but as I go out, what's the height of my cylinder? The height of your cylinder is this. And this is just the y value of f of x. Like whatever this line is, whatever this function is, the y value of that is the height. And the y value of that is this. So then that's square root of 49 minus x squared.
Is it just x because you're doing it in terms of x?
So, okay. So you got to think about radius, right? So when I'm expanding this thing out, right? This is my
I'm talking about the r, by the way.
Yeah, I'm going to show you why. So radius always refers to the distance from your axis of rotation to the outside of your cylinder. In this case, that distance is just x.
Oh, I see.
Right? It's not anything funny or special. It's just x. If your axis of rotation, let's say your axis of rotation was here, okay?
Yeah.
Then r, and let's say this is like x is equal to like -1, then r would be equal to 1 plus x.
Oh, I see.
So you gotta be careful. That's like,
Oh shit, not good.
you gotta be careful if that like fucks up.
Okay.
Okay. So, and the reason why this is now a really nice integral to do. Okay. Racist joke.
Surprise, motherfucker.
Anyways,
Is that a
okay.
racist soundboard?
Racist
Did you add the fa? Did you add the
There you go.
fa?
I just did. Yeah, it's there.
Yeah.
Okay. This is a really easy integral to do. Because you can do u substitution, because whatever is here is also the derivative of it is located outside here.
Okay.
Yeah. So this is the shell method.
Yeah.
Okay. Let's show what it would be with washers, because washers I think is a little trickier. I'll show you why you don't. Yeah. I mean, the teacher just wants you to write the integral. Oh, you have to evaluate it? I mean,
No,
we can go.
you don't have to. You don't have to. I know how to solve that.
Okay, you know how to solve integrals? Okay, great. Okay, so in the washer method, okay, which I guess technically this is a disk because there's no hollow thing, okay, you're building a bunch of, like, disks, but you're integrating them down this way. So right off the bat, because I have a vertical axis of rotation, this is going to be dy. Because what I'm doing is I'm building a bunch of these going this way. Yeah. Whereas here, I was building a bunch of cylinders that were like going out this way.
Oh, because it's x, yeah.
Right, yeah, okay. So this is dy. And dy, again, also goes from 0 to 7. Make sure you use like positive numbers, okay? And then this is pi. And then this is going to be r squared, right? That's just what the washer method is. It's pi r squared.
Yeah, the formula.
Yeah. Okay, so then r. R refers to this. Okay? Which, this right here is what I say is like the x value of f of x, of like this thing. Right, so as we like go along this function, wherever I am, the radius is the x distance. It's not the y distance of this point. It's
Yeah.
it's how far it goes over an x. But the issue here is that I need to make sure r is in terms of y. This is where it's a little counterintuitive. I need how far it is in the x direction, but I need that in terms of y because I'm doing a dy integral.
Right.
So I have to rearrange this because right here I have y is equal to 49 minus x squared, square rooted. So you can square both sides. And this would get me y squared is equal to 49 minus x squared. And then so I want the x value. So then x squared is equal to 49 minus y squared.
Right. In terms of y. I see
In terms
that
of
you
y. You square root it, right? You get positive, negative, but I want the positive one, right? I want the positive x value.
Okay.
So you get positive 49 minus y squared. Okay. So then this comes into here. 0 to 7 pi. Oh, it's actually kind of nice because this squares anyways. So it's r squared. So if this is equal to r, squaring it now just becomes 49 minus y squared.
Yeah.
dy. Oh, now this is super easy. This is a much easier integral to deal with.
Okay.
Yeah.
I see. So, but that one's just r squared. I've seen ones where the washer is like r squared, like capital R squared minus lowercase r squared.
Yeah, so that's if there's a hollow point. So
like the whole, yeah.
Yeah, so if your axis of rotation was here, for instance, r outer would have been a mess because it would have been this, for instance, plus whatever this gap is. Let's say this gap was like 2 or something. And then that would have to get squared, and that gets messy. And then r inner would just be equal to 2.
I see why you add it because since it's on the left side of the graph, right? But if it was on the right side of the graph, you would subtract it.
Well, yeah. So, yeah, that's the other one. So if your axis of rotation was over here, for instance, you can't have it in the middle. You can't be rotating when it's in the middle of the thing. In that case, whatever this r is actually equal to whatever this value is. Let's say this was equal to like 9, and it would be 9 minus whatever this is, like square root of whatever. Yeah. I have video. I have like a 4-part video series on this that does all the major ones. If you go to my TikTok, go to here. See how it says volumes of revolution, harder volumes of revolution, even harder, and then like vertical. Just watch all 4 of these videos. I go over the 4 like fuckery cases that they try to mess with you on.
Same name on TikTok, right?
Same name on TikTok. Yeah, it's also it's the same as if you like YouTube better, because I don't know, sometimes there's too much like rot on TikTok. If you go to shorts here under actual education, it's the first 4 right there. Part 1, part 2, part 3, part 4.
Okay. I think I only saw one of those, and I was waiting for the other one when I was actually practicing.
Oh, yeah.
But now I'm reviewing, so like I completely forgot all of it.
Yeah, go through all of them. Go through all of them. HG says, I saw you on shorts. I saw you gold. Nice. Yeah, the algorithm knows. All right, good to see you, Red Roach.
Too, bro.
I appreciate it. Yeah, I mean, we're doing okay, so I'm happy. Okay.
All right,
cool.
Thank you.
You're welcome, dude. Bro, I went to this Italian restaurant. I swear to God, I saw your twin. Who's my twin? Everyone says I look like Adam Sandler. I'm pretty sure that's my Choppelganger. Right? Gotta be my Choppelganger. Boom. Alright, let's see. Let's add that in. Nice. Oh, you know what I'll do? Also, yeah, I'll put the links for what the videos are too. 1 second. Just there you go. There's part 4. And they all link, so I think there should be like, when you click here, it's like, oh, go back to part 1, go to part 2, go to part 3, go to part 4. Okay, sick. All right, looks like we're out of time, and we did all the questions. I'm happy. Let's close out the stream. All right, thank you everyone for coming to Actual Education Office Hours. Appreciate all the questions. Appreciate you guys chat. Everyone, you guys are awesome. Thank you for helping me learn, and thanks for learning with me. It's a lot of fun. Our next stream is gonna be tomorrow. That's going to be at... So if you ever want to figure out when we stream, go to the website, actualofficehours.com. You can click here on the streaming schedule. And here's a nice little calendar that shows everything. So I will double check tomorrow afternoon to make sure Narowski's awake. But we're going to do... We have on the schedule to do a gilded method thing. So this is fun math proofs and competition-style questions. And then we're going to play Roblox afterwards. So come on by. That'll be fun. If you need more help with math, looks like Zach has another homework help session on Saturday. I need to remove this one on Sunday. I won't be here. But then Monday will be our next, like, actual stream. Okay. Let's go raid someone on Twitch. Let's go say hi to our friends. Appreciate all you guys for sticking through all the struggles. We had a lot of fun. I felt like I just went to the math gym today, dude. There were so many questions. Actual streaming. Yes, and if you want actual coding, please watch Zach's stream on Monday. Let's see. Who are we going to say hi to? So many people on these days. Let's go say hi to Nerduino. I like Nerduino. He's fun. He does like cool Astro stuff. All right. Enjoy the rest of your week. We'll see you Friday for math and games. If not, we'll see you Monday for homework.
Oh, yeah.
Peace.
I used to code in 4chan and 4chan 90. I don't think that would be it. I don't think that would be a good choice.
Please,
Actual education, welcome in. How was your stream? How was your stream? You heard 4chan eat to the 2i pie. How you doing? IBM looking for jobs. Wait, IBM looking for jobs. What? Welcome in. Good to see you. COBOL. I mean, COBOL was good if you Y2K. I don't really know if it's... You get paid a lot of money if you can write code in COBOL. Oh yeah, they did for sure. If you're not using punch cards, what are you even doing with them? Like, this is also true, Jesterweld. I mean, the punch cards are really the way to go. We did used to store backup data on magnetic tapes for Planck. Used to learn Python in high school, but I forgot about it.